What's up guys? Welcome back to another simplified astrophysics video. This video is going to be another video on the stars. I'm going to be talking about the star that is closest to us and most vital to us here on Earth, the Sun. Let's get started. Alright, so let's start things out real basic. The Sun is not a planet, the Sun is not a comet, and the Sun does not orbit us on Earth. And also the Sun is not made out of cheese or eggs or whatever. The Sun is a star, more specifically a yellow dwarf star. We on Earth orbit the Sun every 365 days, which just defines 1 year. And the Sun is an extremely bright and hot object. It's composed primarily of hydrogen and helium, like most stars, and it has a temperature of around 20 million Kelvin, which is quite fiery to say the least. As for its size, well, it's pretty big. The Sun has a volume about 1.3 million times that of Earth, and the Sun has a mass about 333,000 times that of Earth. The specific mass of the Sun is about 2 times 10 to the 30th kilograms, which we call 1 solar mass. In astronomy, we use the units of solar masses to describe the mass of many other celestial objects. Let's shift our attention to the structure of the Sun. The Sun has 6 regions or layers stacked on top of each other, just like in Earth. From innermost to outermost, those 6 regions are the inner core, the radiative zone, the convective zone, the surface or the photosphere, the chromosphere, and the outermost layer, the corona. One of those layers, the corona, is not usually visible. The corona is the outermost ring of light on the Sun, and it's usually blocked by the shining of all the other light from the Sun. However, during a total solar eclipse, when the moon blocks the Sun, the corona becomes visible, as shown in this photo here. The Sun derives energy to support itself and radiate outwards from its inner core. In the inner core of the Sun, a process called nuclear fusion energy takes place, which uses isotopes of hydrogen and helium to create 100% efficient energy without producing any waste. The way that nuclear fusion energy works is through collisions of atoms in the Sun's core that are only made possible by the extremely high temperatures that are present in the inner core. 2 atoms of hydrogen will collide with each other to form isotopes of helium, and those 2 isotopes of helium will further collide into each other to form other isotopes of helium. In the process, a huge amount of energy is released, governed by Einstein's famous equation E equals mc squared. I've talked a little bit about nuclear fusion energy before. Because it is 100% efficient, it produces no radioactive waste, no carbon emissions or greenhouse gas emissions. Earthlings like us would love a nuclear fusion reactor, but it has proved to be no easy task to make. The Sun has various amazing phenomena taking place on its surface. An example of this are sunspots and solar flares. Sunspots are these really dark spots on the surface of the Sun that are much cooler than the rest of the surface by about 2000 Kelvin. The cause of these sunspots is differences in magnetic field strength and activity. Sometimes, some magnetic field activity can occur at sunspots that causes a sort of explosion called a solar flare. This solar flare releases a huge amount of radiation into the atmosphere from the Sun. And those solar flares can release charged particles with them. And that release causes a beautiful sight we hear on Earth, the aurora borealis or the northern lights, something you might see up in Alaska. Pretty cool, right? So let's now shift our attention to the Sun's position in the larger universe. The Sun is obviously much bigger than us, but some people wonder how significant it is in the larger universe. Is it the center of our galaxy, or is it the center of our universe? When we compare the Sun to the rest of our universe, it actually seems quite insignificant. There are many stars that are much bigger than our Sun. That's why we have a unit called solar masses. Additionally, the Sun has no special or significant position in the universe. It's sort of randomly placed in the side of one galaxy. our galaxy, at a safe distance from the black hole at the center of our galaxy. Finally, let's touch on the fate of the sun. What's going to happen to our sun down the road? Will it exist as normal, or will it explode? Explode! Yeah, that. Well, you can probably guess that the sun will die eventually. When the sun runs out of hydrogen fuel, the hydrogen it uses to power its nuclear fusion energy, that is when it will die. The sun will first explode into a large red giant star, and it will then destroy several of the planets that orbit it. A few billion years later, it will cool down and become a stable white dwarf. But you don't have to worry about that happening anytime soon. It won't start till at least about 5 billion years from now. Well folks, it is time to wrap up this video. I hope you enjoyed the video, and as always, I really hope you learned something new. If you did enjoy that video, please hit that thumbs up, that like button down below. And if you're new to this channel and you enjoyed the video, well, don't forget to press that subscribe button as well. Also, comment down any questions down below. I will do my best to get back to you. And I will see you in the next video.